Hello everyone. Today I will show the solutions to the Prairie Math League High School Round 139 Problems 5 and 6. For Problem 5, we wish to find the number of two-digit positive integers that are divisible by both of their digits. So for this question, let the digits be a and b, so let the number be 10a plus b. Now notice that a and b cannot be equal to 0 because divisibility would fall apart in that case. So we only consider 1 less than or equal to a, b, and less than or equal to 9. So then note that because of divisibility, we have the following two divisibility relations. Now, this symbol just means that this divides this, in case you weren't sure. Now, by Euclid's algorithm, we see that a appears here and a multiple of a appears here. So this cancels out, and we have a divides b. Similarly, b appears here and a multiple of b appears here. So this cancels out, and we have this, b divides 10a. Now this means that b can only be equal to a, 2a, 5a, or 10a. Now we see that out of all of these, a equals b has solutions from 1 to 9 because we can have 11, 22, all the way to 99. For 2a equals b, we only have 1a from 1 to 4 because we have 12, 24, 36, and 48. And notice that if we have 5 here, we can't continue the pattern. And finally, 5a equals b only has a solution for a equals 1, in this case 15, and then you can't even continue there. And 10a equals b doesn't even have a solution, because same reason here. This gives us a total of 9 plus 4 plus 1 from these three cases, which worked. And so we get 14, which is option choice D. Now for the second question, we have Catherine, who is standing at the door of her house facing outside. Every time she tosses a coin, if it lands on heads, she takes 1 step forwards, in this case forwards, and if it lands on tails, she takes 1 step backwards. After tossing the coin 10 times, Catherine ends up at her starting point. And how many ways could this have happened if Catherine never stepped outside of her house? So, in this case, we consider a one-dimensional number line that terminates here, and she never goes past this. Now, the trick here is that we can assign stepping back as open parentheses and stepping forwards as closed parentheses. In other words, we can assign this to be the case where he rolls it tails, and in this case, if he rolls or just coin flips and gets ahead. Then we can just see that for any sequence of tails and heads that works, so like tails, heads, tails, 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 heads, tails, heads, so heads, tails, heads, any sequence that results in this condition satisfying actually has a corresponding parentheses relation with this. And notice that this is actually the required relation for the Catalan numbers. So this entire problem of tossing the coin 10 times just becomes the 5th Catalan number, which is 42. So the answer is B. And for reference, the nth Catalan number is 2n choose n divided by n plus 1. Now remember this because, don't forget this the way I forgot this in round 136. If you want to see more Catalan number of problems, check out problem 6 of high school rounds 136 and 138. Stephen has a really nice solution in round 138, problem 6. Anyways, thanks for watching.